about economic benefits of energy conservation in modern construction. As a part of this, I'm going to compare between the old construction and new construction, and look at what are the economic benefits in terms of energy, conserving the energy. Um, this is basically based on a couple of submission in this, a couple of publication in this area. Now, as far as the household energy is concerned, the heating and cooling accounts for about 40% of the household energy consumption in Australia. So what, the last, the 20-25 years, the space heating has increased by around 12% per house. And we expect this to sort of increase in the coming years because of the climate change, which we are already experiencing. Quite often we have extreme heat wave and also extreme cold wave. So because that both of our heating and cooling is going to increase. I don't think any of us, at least in Sydney, can survive without an air conditioner now. So if you look at the total energy consumption within the house, the space heating is around 40%, and the water heating is around 23%. Appliances like the cooking, the appliances and some of those would include around 30%. And then the lighting is around 7%. So, the lighting is a very small fraction of the entire energy required within a house. So the space, the heating and cooling is the main the majority component, which is around 40%. Now we can use some passive strategies for reducing the energy load, particularly on the space heating and cooling. That is, something to do with optimizing the building materials by using higher thermal mass with the floors and walls, and also the better insulation. Now, especially in the eastern part of Australia, building orientation is very, very important. The orientation will help you to save energy, particularly during the winter time. And you need to have an appropriate windows to wall ratio. This is what exactly is mandated by basics in New South Wales. And they you need to have a proper glazing, cross ventilation, and shading. Internal and external shading, in order to conserve energy within the building or within the residential house. Now, I think a lot of us are familiar with this NSW, the Building Sustainability Index basics. So basically gives us some credits based on our design of our residential houses. So we need to we would like to maximize the energy conservation using some of these guidelines. So as you all know that we need to get the basics certification before we start building any new house. Now, I think it's, when we are doing a designing of a house, identifying the climate zone is very important. Now, Australia has got a different climate zones depending upon the location of where you are. So something like this, so you've got a hot and humid climate on the top end of Australia. Like in the case of Darwin, whenever you listen to the news, you always see around 33 degrees centigrade, the temperature there. So which is the hot and humid condition throughout the year. And then if you go towards the eastern side of the country, so you'll get into a more of temperate, the conditions, which is the cool weather, and also the very very nice weather conditions for better living, I suppose. And along with that, you have a well defined the seasons, the 4 seasons. And so during the winter time, you will have to have some heating arrangement within the house, and during the summertime you will have some cooling arrangement within the house. So the heating and cooling comes into picture on the eastern side of the Australia. So you got in a different weather conditions across, as you know, Australia is a big continent. So we've got different weather patterns depending upon where you are in Australia. What we did was we did some we sort of created different scenarios with different building materials, and we sort of simulated some of these scenarios using an energy simulation package, which is called EDA eyes. So using EDA eyes, we simulated what is the heating and cooling energy requirement across all 4 seasons: summer, winter, spring, and autumn seasons. So we sort of compared all those energy requirements. We sort of created about 10 scenarios. So for each one of them, we worked out what is heating and cooling requirement. So the materials what we looked at were, some of these old, low thermal mass, the buildings, which include the fiber house, raised timber floor, and fiber house with better flooring, where we considered, some kind of tiling of the flooring system. So we included this old type of fiber houses, and then some new constructions, which include brick veneer, reverse brick veneer, and double brick walls. So we divided all those into about 10 scenarios. So we consider what is known as PSEEDs. So PSEEDs is passive solar energy efficient design strategies. So which basically includes, the orientation to north, particularly for Sydney, and also, the internal, external shades and double glazing and some of those things. So we analyze with PSEEDs and without PSEEDs. So with PSEEDs means we have got all these passive solar design strategies. Without PSEEDs means we don't have those the design strategies. So we sort of created those 10 scenarios, and then we simulated all those 10 scenarios. Now, what exactly mean PSEEDs? Now, the PSEEDs is passive solar energy efficient design strategies. So house with PSEEDs and house without PSEEDs. So house with PSEEDs we consider as an improved house, which includes a double glazing, and then with a certain U value there, and orientation northern, shading devices, internal integrated window shading devices, and also the ventilation. Means we are assuming here that the houses with PSEEDs have low level of leakage of air into the house. Whereas on the other side, we have got a house without PSEED, so where you've got a single glazing system. Here again, we are still looking at northern orientation. No shading devices are used yet. and the normal infiltration means there is quite a bit of infiltration of air into the house. So here we are looking at 0.5 and here is 2. That's almost 4 times higher. So there's quite a bit of air leakage in these houses without PCs, and also all the glazing is a single glazing system. So that's a difference between the house with PCs and the house without PCs. Now, when we simulate the energy requirement for all these 10 scenarios, so the blue one is for the cooling energy requirement, and the red is a heating energy requirement. You can see that in the case of the standard houses, standard houses means without the PCs. You can see that there is a bit of energy requirement in terms of heating. Whereas if you go for improved houses where we include PCs in the design, so the heating requirement is pretty much very, very low. So that is what has been picked up by this software. So the energy requirement for heating can be drastically reduced by incorporating some of these passive solar design strategies. And also we can see that the fibro houses have got a higher energy requirement compared to something like a improved the brick veneer and double brick houses. So in fact, I think the reverse brick veneer has got the lowest energy requirement in terms of both heating and cooling. Okay, so that gives again this is the totally done by energy simulation using a package called IDA-ICE, which is which is sort of developed by a Scandinavian country, and we have done a few studies in Australia using this particular software. So looks looks reasonable to me, these results. Now, what we did was we also looked at the economic cost of these designs. We did the economic value of energy consumption over 50 years time. So we are considered for the next 50 years, if you're going to continue with using HVAC system, that heating and cooling system for each of these houses for the next 50 years, what would be our net present value? So net present value means we are considering the the interest rate on these the cars, the energy cars, and using the interest rate, we work out what is the net present value of all those investments which you're going to do for the next 50 years towards paying a bill, towards paying the electricity bill. So out of all that, for the next 50 years, improved sort of improved reverse brick scenario is has come out to be the lowest, around 78,000. And a fiber house without the PCIDs, that's the passive solar design strategies, has come out to be the most expensive, that 250,000. So it's almost 3 times the total energy cost for next the 50 years. And if you look at the improved reverse brick the scenario and the improved fibro scenario, here in this case we have got the reverse brick house and fiber house there. Between those two, again, there is almost 2 times difference. So So does this indicate that, we demolish one of these fiber houses and build a new house? Yeah, so this should give some kind of incentive for people, if they're looking at, although it will not be able to recover the entire money of, constructing a new house, at least you'll be able to save some money on energy consumption. So again, a lot of these, the calculations we have done based on the current energy cost or energy rates. These energy prices can change. So in the next 50 years, the energy price maybe is double what we have now. So because of that, it would be super economical, I suppose, to build to demolish existing fiber house and then build a new brick veneer house. So there's some the cost offset we can get by reducing the energy cost with a new modern construction. We also did some real life comparison. So we got two houses here. One was, at the same place. We had there was a fiber house, and that has been replaced with a brick veneer house. So we consider this as a case study, and we looked at the based on the electricity charges for both the houses. We sort of compared the electricity usage per meter squared per day. So for the winter, spring, summer, and autumn. So you can see that winter and spring, there's quite a bit of reduction in the electricity usage for the modern houses. If you're looking at kilowatt hour per meter square per day. So that does indicate, there is, the saving by going with, the new modern construction compared to the older houses. And we looked at the overall, the savings in the electricity usage. So old fiber house was 31 per, the kilowatt hour per meter square per year. And the modern brick veneer house was 23 kilowatt hour per meter square per year. The saving was almost 35% there. So in conclusion, so it means both the real data and as well as the simulation data seems to indicate the modern brick veneer houses can save between 35 to 50% in energy consumption compared to fiber houses. And we'll be able to achieve this is the reduction in the energy consumption that will result in cost saving in the energy bills, and I'm sure these savings will increase as the power bill, the rates, the energy rates are going up. So it will make a sense, to some extent, to replace the old fiber house with new brick veneer house. Again, this is only based on the economics, but we haven't really considered the environmental issues yet. So environmental issues, the reducing the energy consumption can result in the carbon emission reduction as well. And there will be more comfort in living. There's a social benefits, there is an environmental benefit and social benefits, which if you consider, it definitely stacks up about using modern construction to replace a old building. There are a couple of these the papers we have published on this. I think you can access some of these, I suppose. Okay, that's all I wanted to say. I'm happy to take questions if there are any.
Okay, I'm just gonna let everyone unmute and start the video, and we can start question and answer time.
Okay, can I ask a question? So there are two tables, Dr. Hagare, I've found. One was for the net present value of was it for the savings or was it the cost associated with implementing those environmental actions?
Yeah, so in that, so let me just share
The scenario number 5 had
yeah.
the lowest amount of net present value.
Mm-hmm.
And I was wondering if it helps in the savings, or is it actually a cost accrued?
Is a cost. It's a cost. See in this one. Can you see my table?
Yes.
Yeah. So in this, what we have done is we have considered the cost of the energy cost for the next 50
Okay.
years, and also in the case of PSEDs, that's the passive solar design strategies, we have also included the cost of implementing the shading devices and double glazing and some of those things.
All right. So this is actually going to be added to the final value of a property if we're about to save some energy.
Yeah.
Is it correct?
Yeah, that's right. So in the case of the improved reverse brick, the reverse brick veneers, so the cost of energy for the next 50 years is $78,000, and whereas in the case of the standard fibro house,
Second scenario,
is 250,000.
which
So
is the
the
highest.
difference between those two is basically because of high energy costs in the case of fiber house.
Yeah. Thank you so much.
Thank you.